Today we'll be looking at polynomials, linear factors, and zeros, section 5-2. Remember from chapter 4, if you were solving this quadratic, you would find that the solutions are x equals 6 or x equals negative 2. This comes from finding the factors. If you factor negative 12 into negative 6 and 2, then negative 4 is made from negative 6 plus 2. So it factors as x minus 6 and x plus 2. This form here is called the linear factors, or the factored form. Then you set each piece equal to 0 and solved, and this came from the zero product property. When you solve those, then you are able to find that x equals 6 or x equals negative 2. These are called the zeros or roots. So, writing a polynomial in factored form. To write a polynomial in factored form, you need to begin with factoring. Remember, the first step of factoring is to look for a GCF. In this given polynomial, the GCF we see is x. So if we take out an x, then we would be left with x squared minus 2x minus 15. Then if we use our theories from the previous chapter, what are the factors of negative 15 that will make negative 2? If we use negative 5 times 3, that will make negative 15. And if we use negative 5 plus 3, then that will make negative 2. So we keep our GCF, which was x at the beginning, and then we have an x minus 5 and an x plus 3. This would be factored form. Because the polynomial started out as an x cubed, then that means there should be 3 linear factors. Here we have an x as your first factor, x minus 5 as your second, and x plus 3 as your third. So, now you try. What is the factored form of x cubed minus x squared minus 12x? Pause the video, try and factor this, and then replay to see the answer. Alright, so the factored form of this, we start by taking out the x, and then when you do that, you'll have to find the factors of negative 12 that make negative 1. So it gives you x plus 3 and x minus 4. Alright, key concepts on zeros. If x minus b is a factor of a polynomial, then b is a zero of that polynomial. B is also called a root of that polynomial, and then when looking at the graph, b is also the x-intercept of the graph. So if we look at the previous example when we had the factors x plus 3, and x minus 4, then x equals 0 is a 0, x equals negative 3 is a 0, and x equals 4 is a 0. Anything that is a 0 is also known as a root. Anything that are zeros or roots become x-intercepts on the graph. So if I asked you to graph this, all 3 of these would be points on the x-axis. So here's an example. X squared minus 4x minus 12. What are the factors of negative 12 that make negative 4? Negative 6 times 2 makes 12, and negative 6 plus 2 makes negative 4. So it factors as, so your factors are x plus 2 and x minus 6. This makes the zeros negative 2 and 6. Your roots are also negative 2 and 6. Therefore, the graph intersects the x-axis at negative 2 and 6. As you see here, you have an x-intercept at negative 2 and an x-intercept at 6. Finding zeros and graphing polynomials. what are the zeros of this function? And then we are going to sketch the graph of the function. So we begin by taking each of the factors and setting them equal to 0. So we're going to use the zero product property and say 0 equals x plus 2, x minus 1, and x minus 3. So we can say x plus 2 equals 0 and find that x equals negative 2. We can say x minus 1 equals 0 and find that x equals 1. And then we can say x minus 3 equals 0 and finally find that x equals 3. We have 3 zeros, which means that this is a cubic function. Now we're going to determine the end behavior, plot our intercepts, and sketch a graph. The end behavior would come from multiplying the first term of all 3 parentheses. We multiply the first terms, we get an x cubed. Because it's positive and an odd power, we're going to be going down and up for our end behavior. So now we sketch a graph. We have an x-intercept at negative 2, an x-intercept at 1, and an x-intercept at 3. Our end behavior starts down and works its way up. We're not concerned right now with how high or how low those turning points go, just the fact that they are there. You will learn later how to find those. So now you try one. What are the zeros of this polynomial? And then sketch the graph. Pause it, work it out, and replay it when you're ready to see the answer. For this one, your zeros would be x equals 0, x equals 3, and x equals 5. Once again, take the first terms of each one and multiply it, and you find that your first term is an x cubed, making the end behavior down and up. So when we sketch the graph, you would have, this one is a negative 5. You would have an x-intercept at negative 5, one at 0, and one at 3, starting down and working your way up. Next thing we're going to look at is writing a polynomial from given zeros. This time you're going in reverse. They're giving you the answer and you have to find the polynomial that it came from. So, what is the cubic polynomial function in standard form with these zeros? If these are the zeros, then you know that if negative 2 is a 0, it came from the factor x plus 2. If 2 is a 0, it came from the factor x minus 2. And if 3 is a factor, or 0, it came from the factor x minus 3. Remember, to be a 0, when plugged in, it needs to make 0. So if we plug in negative 2 plus 2, that makes 0. If you set it equal to 0 and solve, it would give you the negative 2. To write the cubic and polynomials, or to write the cubic polynomial function, we need to begin by distributing. So we're going to say x times x is x squared. X times negative 2 is negative 2x. 2 times x is plus 2x. And 2 times negative 2 is negative 4. Add together your like terms, and you get x squared minus 4. Then bring down your third factor and distribute again. So we say x squared times x makes x cubed. X squared times negative 3 makes negative 3x squared. Negative 4 times x makes negative 4x. And negative 4 times negative 3 makes plus 12. So the cubic function in standard form is y equals x cubed minus 3x squared minus 4x plus 12. Now you try one with these 3 zeros. The answer for this one is y equals x cubed minus 3x squared minus 9x plus 27. You should have found in this one that you had like terms that you would have needed to combine. Last thing we're going to talk about is finding the multiplicity of a zero. Multiplicity is a zero that appears n times as a zero, meaning it appears more than once. For example, x plus 2 squared is a zero, x equals negative 2, with a multiplicity of 2. Because x plus 2 squared means x plus 2 times x plus 2. So you have the zero, x equals negative 2, but it is happening twice, which is why we say with a multiplicity of 2. So what are the zeros of this one? And state their multiplicities. So we're going to start with the function f of x equals x to the fourth minus 2x cubed minus 8x squared. First thing, if we're looking for zeros, we need to set it equal to 0. Next thing, we're going to begin factoring. When factoring, first thing we do is look for a GCF. Notice that all of these have an x squared term in them. So we can take out an x squared, and we'd be left with x squared minus 2x minus 8. From chapter 4, we learned to factor this by finding what multiplies to make negative 8 and adds to make negative 2. So we can use negative 4 times 2, negative 4 plus 2. So we can continue to factor, leaving the x squared out front, and then we find the other factors to be x minus 4 and x plus 2. The 0 for this becomes x equals 0. Because of the squared, we will say with a multiplicity of 2. This 0 becomes x equals 4. It's the same as if you set x minus 4 equal to 0 and solved. Because there's no power, this has no multiplicity. And then the last factor becomes a 0 of x equals negative 2. Same thing. If we took x plus 2, set it equal to 0, and solved. Once again, because there's no power, this one has no multiplicity either. Here's one for you to try. Try this and see what you come up with. Pause it and replay when you're ready for the answer. Alright, for this one you should find that x equals 0 with no multiplicity, and then x equals 2 with a multiplicity of 2. Now that you've finished the lesson, go open up the assignment, try them, and make sure you bring in your questions.